What's good, everyone? A bit more of a niche topic today. We're going to be specifically talking about the WhisperX model and how we can deploy it on SageMaker Real-Time Inference. And we're going to be using a few familiar constructs if you've already been in the inference series in terms of the Large Model Inference Container. That's what LMI stands for. And then we'll also talk about or revisit something we already covered in the series in terms of how you can kind of debug your inference scripts a little quicker with Docker to kind of simplify this process for you. And the reason I wanted to talk about this model specifically, right, is we've talked about different types of LLMs, but most of them have been in the text to text generation mode or image to text or vice versa, kind of. Audio LLMs are still a large part and have a large use case in many different kind of problems that we can solve nowadays. And I wanted to describe how you can kind of achieve deploying one of these models. Whisper's one of the more popular ones here, popular audio-based models, using SageMaker and the LMI container solution in a pretty simple or standard way, and you can apply this to your own models, to your own use cases as always, obviously. So first, I just want to theoretically revisit a few of these concepts. Most of this will be spent walking around the code itself, and hopefully you can take that and once again import it to one of your use cases. But what we'll do first is we'll revisit the LMI container. So if you remember the LMI container, what it does is it has a open source deep Java library serving stack as its backend. And through the serving stack, it exposes different kind of popular interfaces or popular large language model serving frameworks such as VLLM, TensorRT LLM, and I don't believe it supports this anymore, but something that it used to support was also DeepSpeed, one of the older frameworks, but you can imagine a lot of it is kind of centered around this, and especially VLLM is kind of what's been the industry standard lately, slash what the LMI container integrates with very heavily. So specifically, right, VLLM supports many different model architectures through this backend, and this includes things such as Llama. There's Llama 4, like Maverick, for example. I believe that's what it's called. I might be screwing up the name completely there. It supports the Mistral models and all these different kind of OSS models, right? Where you can enable them basically via a Hugging Face ID, or if you've customized them, you can provide your S3 path to your kind of model data, basically. So it makes it very, very simple when you have your model weights, especially for open source models on Hugging Face, where you have your own custom model kind of artifacts, where you can kind of point that out and then also have all the goodies VLM exposes, such as batching, multi-adapter inference, and things of that sort. There's a lot of kind of inference optimization features that come with VLM, right? So having this native kind of integration with Hugging Face and your model weights to S3 makes it very simple to use. The problem is VLM does not support all model architectures, and there's going to be some times where you're going to need to have a bit of a custom engine. And in this case, especially, right? So Whisper 3 large is supported natively by VLM, and I'll attach a notebook too in a future series in terms of how you can directly port that with VLM. And I'll have the docs down below as well if you're interested in that model. But WhisperX at the moment, at least that I'm aware of, I might be wrong here, but this will be a good proof of concept for any custom models or architectures that are not yet supported. WhisperX is not natively supported yet. So in the case that you have one of these models and you're using one of these model partitioning or model serving backends, right? And they don't natively support it, what DJL does is it exposes a Python backend specifically, and this is a Python engine. And what you can essentially do is you can still work with GPU instances in the different compute, but you can bring your own kind of custom Python code basically to interface with whatever model that you're working with. And here you can provide different kind of serving properties files too, which we kind of explored in the scikit-learn case. You can configure things like min workers, max workers, and kind of load tests across scenarios like that. So this is how many CPU workers or threads you want to kind of allocate per model that you're dealing with. And then you can simply have requirements.txt file as well. So very similar to that scikit-learn use case we talked about earlier in the series, if you want to take a look at as well. But we're going to be applying it to a GPU use case here and an audio LLM specifically. And the reason I brought up the second point in terms of Docker, why I want to revisit that, right, is when we have custom Python code, we want to be able to test this easily, right? Because especially as we adjust kind of maybe our model loading or model pre-processing and post-processing logic, we want to be able to iterate on this and test any changes. We don't want to wait for the SageMaker endpoint to create every time. This is a very tedious process, and especially with larger models, when you have pretty large kind of model metadata files that you need to pull down, it's going to take a while, right? So what I recommend, we won't do it in this video itself, is take Docker, go on a EC2 instance and pick an AMI that has Docker pre-installed ideally. I don't use Ubuntu, and then I think it's the PyTorch deep learning AMI or AMI that I use. I might have butchered some of those things right there. But you can take it there, somewhere with Docker pre-installed, you can pull the VLLM LMI container, and then you can have your artifacts basically. So this will be your model.py, your serving file, and then your requirements, which contains whatever dependencies you're working with. In this case, we're going to be installing the WhisperX library. Pull that, expose the port or the path that's needed for basically SageMaker Inference, which I believe is 8080, and then dash indications. I'll have a sample curl request too. You can pull that, and then you can basically do a Docker run, start your container, and then you can start curling requests, or you can use the Python request library and hit that. And it simulates an endpoint, right? So the EC2 instance that you want to pick should be the one that you want to deploy your SageMaker endpoint on. So if you know you're going to be hosting this, for example, on a G54X large, for your SageMaker endpoint, make sure your EC2 instance is that. Because any load tests or anything that you run, right, you can kind of benchmark and try it directly there. So this will help you kind of fix any quick bugs or anything within your model script ahead of time. And you won't have to spend way too many cycles kind of iterating through this, waiting for your endpoint to create, going through the CloudWatch logs. That will end up being a bit of a mess. So you want to avoid that process, and you can circumvent that by using this kind of Docker container startup and simulating it with the necessary kind of SageMaker invocation paths. So with that being said, let's hop into the code directly. Once again, this is a bit more of a niche video, but I just want to showcase an audio LLM. What we'll be working with here is the WhisperX library. So the traditional Whisper v3, I believe it is, v3 large one, that's directly and natively supported by VLLM. So you can configure this directly through the container and use all the VLLM kind of serving engine parameters that you can tune and things of that sort. But for WhisperX, there's actually a multitude of models that are happening together in the background. Once again, I'm not a data science expert in terms of how the models were built itself. But if you see here in the Python code that they shared as an example, you can see that there's basically many different models they're loading. One for transcription. I believe there's different versions too of this initial model. There's a small version too if you're on a CPU, for example. And then there's an alignment model, and then finally there's a diarization model. So for diarization, I just recently learned this too. This is when you might have multiple speakers, right, in a conversation. If you need to identify the different speakers when they've spoken and things of that sort, those kind of timestamps basically, that's where diarization is very helpful. And you can imagine kind of telehealth type use cases where you might have a doctor and a patient speaking, kind of identifying who's speaking, or maybe there's a group type conversation happening, right? It can basically help with identifying the multiple different speakers. So WhisperX, like I said, at the moment is not natively supported with some of the backends that LMI supports. So with WhisperX, we're going to have to utilize a custom Python engine. So let's take a look at how we can do that. I'm in a SageMaker Classic Notebook instance right now. You could use Studio as well. I realize that installing WhisperX is actually a bit of a pain in the Classic Notebook, so I would recommend honestly going the Studio route. That's where we're going to be invoking it from. But here, if we get here, right, you're going to see a lot of the same SageMaker constructs and things that you're working with. I recommend having a bit of a working knowledge or understanding of that before coming here, because this might be a little foreign and we won't get too deep into these different constructs and APIs. But if we see here, right, I've attached a few Docker commands. This is going to be the LMI image that we're using, the large model inference container image. We'll use the VLLM kind of property there, but we're going to expose the Python engine rather than the VLLM engine itself. And you can see this is how you can start up the container in somewhere like EC2 and maybe like your Ubuntu machine and expose the port that's necessary for inference, and then you can serve this container. So if we come down here, we have the usual tools that we work with, the higher level SageMaker Python SDK, the Moto 3 AWS Python SDK, and with these we set up our clients to interface with S3, where we will have our model data, things of that sort. And then I'm going to deploy this on a G54X large. I think you could do a smaller instance here, so play around with that, and we can take a look. And here, right, once again, what we always need when working with SageMaker Inference is our container that we're working with. And for this container, we've specified essentially, right, our inference image URI, DJL inference, and this is the latest LMI container, which is v16 at the moment of this recording. Now, if we come here, right, there's three different constructs we're going to be working with. model.py, requirements.text, serving.properties. Requirements.text, as you can imagine, is your dependencies that you're installing in your Python environment. And here, right, I really need to stop hard coding these. But here, right, we see our model inference script, and we'll see that we've set we've installed this WhisperX library, and we're going to be working with this basically in the script. So what I'm going to do first is I'm going to check, right, if there's a GPU instance for the deployment, and then I'm also going to check for if it's a GPU instance, we're going to use float 16. Otherwise, we'll use float 32 for CPU-based instance. I recommend you go the GPU route here, just because we're working with a multitude of models with this API. All I'm doing, by the way, in my requirements.text for installation, and I'm jumping a little ahead, is I'm basically going to install the WhisperX library. With that, Torch, NumPy, and a bunch of other dependencies get installed that you need for this. And the reason you need the Hugging Face token there, and I will delete this, I know this is not best practice here, but definitely do not want to get hacked. Cannot afford that right now. But the reason you need a Hugging Face token here is that you need to be able to access some of the different models in this pipeline. The actual diarization model is being pulled from Hugging Face, those model artifacts. So go ahead and make an account and grab a token if you need, so you can access this diarization model. So if we come in here, within this model script, right, like we remember, if anyone's seen the train video that I put out and the LMI video, every model serving engine has a different way it expects for its custom scripts to be present, because it needs to pick up on that code, right? For DGL specifically, this handle method really is the one that does all the magic. And that handle method, it wants to be able to initialize the model and then also parse that and then run inference on the inputs, right, that we're sending in. So here, what we're going to do is we're going to actually load up these models, and this will happen upon container startup, right? We'll load the actual transcription model, the alignment model, and then the diarization model. Now we know our model's initialized before we actually get into inference. So this step right here, this initialize method, only occurs once. We're going to load all these models, keep them warm, right? And then we can see our actual inference logic. So you can think of a sample input as your audio array, and then we're going to deserialize that into a NumPy kind of representation, basically, of that audio file using the WhisperX library on the client side too. And then we're going to parse this JSON, right? Grab that data, and within that data kind of key, right, I'm going to have my NumPy array listed as within this audio array key right here. And I'm going to check that, do some casting basically into a format that we need for our models. And then you can see the 3 different models are happening here. There's not really much that I did. These are, once again, higher level APIs, courtesy of models built by much smarter people here. But what we're going to do is we're going to have that transcription model. We're going to grab that. We need that transcription result to properly align the model. And then the diarization is the aspect, basically, where you can see the different speakers and things of that sort. So for my test MP4 file, right, I only had myself speaking. And you can obviously kind of plug in whatever you want. I'd assume the larger the file, there might be some problems here, some things or knobs that you have to tune. You got to read a little more on the library in that case. But here I run that, essentially execute that, and I parse this final output, and then I'm going to append it into this JSON right here, and I'm going to return it from DGL serving. So really, that's where all the magic is happening. Once again, just your local Python code you can almost think of, right? You can plug it in here directly, and I did not write this in one go. I did not write this without any linting or anything, just in this notebook instance. I went on EC2, like I was saying, and I pulled down that Docker image that we're working with, right? This one right here, and I served the different model artifacts, which in this case is our model script and our requirements.text and serving properties, right? Sometimes if your model artifacts are very large, you might want to put them in a S3 bucket and have them in your serving properties for you to kind of pick up on. The serving properties you can almost think of as OS level environment variables that you can parse. So any other configurations, probably like a token, you might want to put there rather than like just having it out front like me. And basically you can kind of configure anything here. And then if you look at the DGL documentation too, which I'll link below, there's different knobs you can play with, such as min workers, max workers. This especially matters when you have multiple models, and if a certain model is receiving more traffic, right? You want to be able to scale the worker count dynamically for that model. And that's what DGL is very, very good at. So take a look at that if you want to play with that as well, but we keep it pretty minimal here. Next, we go to our usual SageMaker constructs. The model will point towards our container, and then a model tarball, which will basically live in S3, pointing towards these 3 different resources right here. We upload that there, and then we then create a SageMaker model object, which is once again our container image with our Python engine there, and then we have our model data or model artifacts pointing to these 3. We then create an endpoint config, which you can think of as if you have different variants and you're specifying your hardware resources. In this case, we have a G5 4x large, right? We specify all of that. And for larger models, you want to maybe play with these parameters here because you don't want your container to time out. I forget the exact limit there, but you want to set a higher value here. We do that, and then we finally create our persistent REST endpoint, which is the one we can invoke. So in this case, right, in classic notebook instances, there was some problems here. I'm not fully sure why. In full honesty, I'm a bit lazy to debug that. So I just kind of went into Studio. I would recommend running this sample on Studio. And I created a Jupyter Lab space here. And then I just installed WhisperX and then installed I think this is an audio-based library that you need basically. I completely chatted the dependencies on this. But then I took a sample test audio here, right? Which is just me speaking for like I think 10 to 15 seconds. I loaded that audio path, passed in a sample rate. I made this into a format that my server was expecting. And then I instantiated my runtime client, and now I have my endpoint or invoke endpoint API call that I can do. So taking that sample payload, you can see the output right now, and you can see it's identifying speaker 00, which is me, throughout this entire series because no one else was speaking. But you can take this pretty simply and build upon it, right? Let's say you maybe have a real-time chatbot or something where you have multiple people talking, or a call transcription service or something of that sort, right? You can imagine how you can apply this example. But yeah, at a high level, I didn't want to extend this too much more. I know it's a bit more of a niche kind of topic we covered, but audio LLMs are still something that's relevant and that I see a lot of kind of like startups going into, and everything's LLMs nowadays. But audio is also a very powerful feature, right? And something that can also use a LLM with or have LLMs tailored for it. And Whisper is one of the most popular ones. And anytime you're using the LMI container, right? Now, if you have a model, right, that is not natively supported by one of the backends, even if it's not WhisperX or this use case, you now know how to kind of bring it natively on there if it's not a supported model architecture via the container. But yeah, thank you as always for watching. I will leave all the resources down below. If you have any questions, as always, feel free to drop them in the comments. Reach out to me directly via LinkedIn or Twitter. If you enjoyed the video, feel free to leave a like and subscribe. I'll be back very, very shortly with much more. Thank you, everyone.